This lesson is over trapezoids, rhombuses, and kites. The objective is students to be able to find the area of trapezoid, rhombuses, and kites. So first off, we're going to prove the area formula for trapezoids. We'll go into a little bit more about what trapezoids are here in a second. So if you take two of the same trapezoid, they actually form a parallelogram. So if I take this trapezoid and I give you an exact one, but then I flip this one upside down, if we just put those together, they form a trapezoid. They form a parallelogram. So to find the area of this parallelogram, remember the area is the base times height, so that's the height. Well, the area of this parallelogram, the base is that whole thing. Well, that base would be B1 plus B2 because it's the whole thing. We multiply it by the height. So that would give us the area of this whole parallelogram, but I don't want the whole parallelogram. I just want one of the trapezoids. Well, if two trapezoids make up this parallelogram, then one trapezoid is going to be what we're looking for, which is going to be half of that formula. So it's half of the height multiplied by base 1 plus base 2. So you see that formula here. So a trapezoid has exactly two parallel sides called bases. So a trapezoid is a quadrilateral. It's got four sides, and two of the sides are parallel to each other. The other two are not. The height is the perpendicular distance between the bases. So we've done that before. So let's do some examples. A car window is roughly shaped like a trapezoid. Find the approximate area of the window. So this is the window we have over here. So they give us the 28, 20, 19, 36, and they give us this 18. That 18 is a height. The bases are the parallel lines. So don't think the 28 and the 19 are our bases. We actually don't need those at all. So we have this base and this base. Then we have our height. So the formula, 1/2 times the height, base 1 plus base 2, is 1/2. The height is 18. Base 1, doesn't matter which is which, so might as well call it 20 and 36. Now, from here, you can type that in your calculator exactly how you see it. You just have to make sure you use parentheses here because you have to add those before you multiply anything. So for me, instead of putting that in my calculator, I just take 20 plus 36. That's 56. And this is where I put it in my calculator. Now, again, you could technically do this one. Just make sure you're using all your parentheses because this is where a lot of people miss it. They don't use parentheses. They just put 0.5 multiplied by 18 multiplied by 20 plus 36. That's going to give you the wrong answer. You have to put that one in parentheses. So like I said, I would just, to avoid that, I would just add them first and get 56. And this is what I put in my calculator. 0.5 times 18 times 56 is 74.5. And I don't know if those are, I guess I would say those are probably inches. But again, I'm not too finicky on the units. So go ahead, do this one on your own. Pause the video, do this on your own. When you're done, hit play so you can see the answer to this. Make sure you did it correctly. So what's the approximate area of Nevada? So this one, the bases are this base and this base. So this trapezoid is kind of pointing up and down, which means this 309 is the height. Well, that doesn't make any difference. 1/2 times 309 times base 1 plus base 2. We're not multiplying those. So 205 plus 511 is 716. And now we multiply those. 0.5 times 309. Oops. 309 times 716. We end up getting 110622. So that is 110,622 miles squared. Number 3, find the area of the trapezoid. Well, when you look at this area of this trapezoid, kind of like what we did in the last lesson, the trapezoid, I need the bases, but I also need the height, and we don't have the height. Well, to get the height, we're going to have to find out what that height is. So they give us the 13. We're going to look at this triangle here. Oops. Let me make that a little bit more obvious. So we're looking at this triangle here. And we have the 13, we have the hypotenuse, but we also don't have this length over here. But we can use some math with this. I know this length is 11, so this length has to be 11. Well, if the whole length is 16 and that green length is 11, what's that leave for that blue length? Well, that's 16 minus 11 is 5. So that length's got to be 5. So occasionally you're going to have to do this to find out the base of that triangle. So now I can use Pythagorean theorem to find the height. So to find the height of that, we have h squared plus 5 squared is equal to 13 squared. And this is, again, the same thing we did in the last lesson. H squared plus 25 is equal to 169. Subtract 25. H squared is equal to 169 minus 25 is 144. And don't forget, take the square root of both sides. I know this isn't drawn to scale, but the height being 144 is a little bit extreme. So the height for this one is 12. So now we can plug it into the area formula. So the area is 1/2. The height was 12. Base 1 was 11. Base 2 is 16. And again, it doesn't matter which one you do. It's base 1 and base 2. 16, 11, 11, 16. Doesn't make any difference. 11 plus 16 is 27. And then that's what I put in my calculator. 0.5 times 12 times 27 is 162. That'd be feet squared. So again, try this one on your own. So this one, they know the height, but they don't know the base. We know this one's 5, but we don't know the second base. But again, you're going to use the Pythagorean theorem to find that. So go ahead and do this on your own. Pause it, do it on your own, and then hit play to check your answer. So I can look at this triangle, and so I know that it's going to be 8 squared plus, let's just call this x for right now. X squared is equal to 10 squared. That's 64 plus x squared is equal to 100. Subtract 64. X squared is equal to 36. Take the square root of both sides. I get x is equal to 6. So that is this length right here is 6. But that doesn't tell us the whole base. That's just that blue part. So to find the rest of it, you have to remember, just like we did in the last one, if this is 5, this is now a rectangle. So if that top part is 5, then this bottom part is 5. So the whole thing is 5 plus 6 is 11. So now we have one base, two bases, and our height. So now we can plug that in. 1/2, 11, oops, sorry. 1/2 times 8. I like to put the height first. Then the base is 11 plus 5. So that's 1/2, 8 plus, or sorry, times 16. 0.5 times 8 times 16 is 64. That'd be meters squared for this one. So next thing we're going to do is moving on to rhombuses and kites. And these are very similar. So again, I'm going to prove this one a little bit really quick just to hopefully help you remember it. If you cut a rhombus in half using the diagonals, it forms two triangles. Or using, I guess it says the diagonal, forms two triangles. The base of those triangles are the diagonal. So if I just take this rhombus right here, and again, we'll discuss what a rhombus is, but if I cut that in half like that, it forms two triangles. So I want to know the base and the height of those triangles. If I have the base and the height, then I can figure this one out. So the height of this one, if we just look at this triangle, well, that's the other diagonal, but it's only half of it. The other half is over here. So really, I guess I said that this is a proof, and it's really, yeah, I guess we could do that. So the first diagonal I'm going to call D1. This is maybe getting more into what I want to do. I'm going to call this one the height. So let's just look at the left triangle. So the area of that triangle is 1/2 base times height. So it's 1/2 D1 times H. Now, we cut it exactly in half. So we're actually going to do, let's just see the best way to describe this. Basically, we're going to do two of those. Okay, this is going to be a disaster, but that's okay. So we're going to multiply that by 2 because we have one triangle here and one the other one. So it's 2 times 1/2 D1 times H, which is just D1 and H. Now the problem is the H was just this half. So we're going to be using, instead of just that h, we're going to use the other diagonal. That's the full thing. So this is going to be more of a nightmare than I was thinking. And if I redid it, there's some other ways I would have labeled things to make life a little bit easier. But that's vaguely where they're going to get it. I'm just going to stop there before we do anything else. So the diagonals of a kite of a rhombus are perpendicular bisectors. So the big thing that I want you to realize with that is when you take both diagonals, this diagonal and this diagonal, not only are they all perpendicular to each other, but they also cut each other in half. So this is congruent to this. This is congruent to this. And the same thing applies to kites. Sorry, this is the area. This perpendicular bisector is not what this is talking about. They're perpendicular, but they're not bisectors for kites. So we'll talk about that in a second. So let's first talk about the rhombus. A rhombus is a parallelogram where the sides are congruent. All four sides are congruent. So it's like a square, except for a square, all the angles are also congruent. So the sides and the angles are congruent. Now the sides are, but not necessarily the angles. So the area for a rhombus is 1/2 the first diagonal multiplied by the second diagonal. So if I take this diagonal and multiply them, and then multiply them by 1/2. Kite is a quadrilateral with two sets of congruent adjacent sides. So the sides that are right next to each other are congruent. These sides are congruent. And again, kind of like the parallelogram, these diagonals bisect each other. They make a right angle. Or sorry, they're perpendicular. They do not bisect each other. I don't know if you need to know this, but this one is bisected, but the longer one is not bisected. So it does help to know that they're perpendicular. And again, the area for the kite is the exact same thing. You multiply the diagonals together, and then multiply by 1/2. So the formulas are the same on both sides. And again, the diagonal in a kite and a rhombus are perpendicular, and I need to change that because the rhombus is a perpendicular bisector, but the kite is just perpendicular. So I need to change that. My apologies. So find the area of the kite. So the kite they give us here, the formula is 1/2 diagonal 1 multiplied by a diagonal 2. We're not adding. That's the trapezoid where we add the bases. So the first diagonal is, we'll look at this one. Doesn't matter which is which. We have 1 and 4, so that's going to make up 5 for the first diagonal. Actually, I don't like that dot, so I'm going to be using parentheses. The second one, we have 3 and 3, so that second diagonal is 6. So 1/2 times 5 times 6 is 15. So the area for that one is 15. So try this one. Again, it actually isn't really too bad. Oops, multiplied, not added. That's 1/2. Diagonal 1 is 7, because they say 7 is the whole thing, how they label it. And the other one is 8, because it's 4 and 4. 25 times 7 times 8 is 28. Sorry, I should have been labeling mine, but I was getting lazy. So I'm assuming they want the area of this one. That's funny because I must not have put the question on here, but that's okay. We'll go ahead with it. So what's the area of this one? So the area of rhombus RSTU. Sorry, I'm going off the page a little bit. So the big thing with this one that's harder is this is a right triangle here. So they give you one diagonal is 12 and 12. So one of the diagonals is 24, 12 plus 12. But they don't give you this other diagonal. So we're going to have to look at this triangle to figure out what this side is, and then we can use that. So just look at that triangle. We have 12 squared plus x squared is equal to 13 squared. So 144 plus x squared is equal to 169. 169 minus 144 is 25. Take the square root of those sides, you get x is equal to 5. That's this length is 5, which means this length is 5. Now we have everything we need to know. Now the second diagonal is 10, 5 plus 5. So 1/2, 24 times 10. 25 times 24 times 10 is 120. Looks like feet squared. And try this last one on your own. Find the area of the following rhombus. This one is kind of, it's not any more difficult, but they didn't put down this diagonal. They just didn't draw it in there, but you can draw it in yourself. That's totally fine. So the first diagonal is 6. They label that one. But again, we don't know the other diagonal, so we're going to have to use this triangle to find it, and I know that it's a right triangle. Remember, those are going to be perpendicular of each other. In the rhombus and in the kite, those are always going to be perpendicular, the diagonals. So if this side over here, oh, the whole side, oh, this is the side we're looking for. Sorry, I should have specified. This is the side, because I know this length is 6, so that means this is 3 and this is 3. So now this is the length that we don't know. Sorry, I thought 6 centimeters was labeling something different. So we have 3 squared plus, call it x, is equal to 5 squared. So it's 9 plus x squared is equal to 25. Subtract 9. X squared is equal to 16. X squared root x is equal to 4. So this side is 4, then this side also has to be 4. So the second diagonal is 8, 4 and 4. And like I said, now the equation is pretty easy. 1/2 6 times 8. So that ends up being 24 centimeters squared. So I think I mentioned it in the last lesson, but really so far, other than formulas, really the hardest part is the Pythagorean theorem. I guess remembering when to use the Pythagorean theorem, but that's the hardest math, is making sure you can solve that Pythagorean theorem. If you have any questions, don't hesitate to ask. Thank you.